Thank you, Rob, and thank you all. I'm going to talk about inline dimensional measurement of fiber cement and other types of products. So, company Limad, some pronounce it Limad, it's up to you. It's a Swedish company, headquarters in Gothenburg, and there we have the design and assembly of the systems, including mechanical frames and software programming. Our main industries is the wood panels industry, gypsum, wood, the sawmills, and the steel industries. We also have some installation in the fiber cement. I'm coming to that. Sweden is a small country, so we work worldwide. So we have subsidiaries in the Americas. Limad in Finland take care of Finland, the Baltic states. Germany takes care of the German-speaking countries. The UK also services the Benelux countries. And then we have representatives in other major markets. And if not, we try to sell directly to the end customers. So I'm responsible for the business area of building materials, and that includes gypsum wallboard, it includes all types of wood panels, and also the fiber cement boards, insulation materials, and other types of material. Basically, with a non-contact laser measurement, you can measure on nearly all types of material. References then, we've been working about 30 years with laser technology, so we have many installed systems, gypsum wallboard. We have about 200 systems to all the major producers, wood panels, about 100 systems to most of the big ones and a couple of the smaller ones. Some installations in insulation materials and other types of materials. Talking about sawmills, that's where we really started. Nearly all sawmills in Northern Europe has Limad measurement equipment. And we also have a lot of installations in steel mills for hot and cold rolling products. Fiber cement, I guess that's the reason for me standing here. We haven't really focused on fiber cement, so we try to improve there. But we have 10+ installations that, with some good references. I believe we have 3 systems at Etenit, and we also have 3 systems installed for National Gypsum and their fiber cement production. And then we have Solid from also included in the ETEX group, as we heard yesterday, in Gypsum and CSR. Here is the measurement principle that works. So, this is a laser diode. It sends out the laser spot, little like this one. And here is the material within the measurement range that you are to measure on. The light from the laser is reflected back to this optical lens that projects the light on this light-sensitive CCD array. So this is basically an angle measurement that we transform to a distance. And then we use, typically the sensors work in pair. So we measure if the panel is moving upwards, the lower distance will be longer, but the upper will be equally shorter. That means that we can eliminate the influence even on high-speed vibrations, because we measure with 2000 Hz constant measurement frequencies, so it's really fast and accurate measurements. If it's not possible to measure double-sided, then we can measure single-sided. That's typically measurement against a belt or a roller or a drum. It needs to be some type of zero or a reference plane. That is typically not so accurate, because the panel moves to or from the sensor, that will affect the measurement accuracy. So we use that when it's not possible with double-sided measurements. And it can be possible to average out errors. For instance, if you have a roller or a drum that is not perfectly round, then you can measure for a longer interval and you can get relatively accurate measurements. This is a sensor we use called the Presicura. It's an accurate and rugged industrial design sensor, not sensitive for color variations. That is important, and we call it sort of intelligent. It has inbuilt digital signal processors. There are a lot of low-quality laser sensors out on the market, but this is a good one. So it has high accuracy. Then into general benefits with in-line measurement, you get a consistent grading. It's not like an operator going there once an hour or so doing random samples. Here we have a continuous measurement, and we also measure in the middle of the panel. That's not so easy for an operator. As soon as you're out of tolerance, there's some problem with the panel, we will alarm you. You can get a sound signal or light signal, and you will see it on the system computer screen that something is wrong. And by this, you get the instant feedback from the system. That means that you can reduce downtime and you can speed up the production when you change from one product to another product. And with this, you can increase your production yield. You can use less raw material and less energy consumption, and less scrap. Another important thing is that you can also perhaps reduce the safety margin you use in your product by lowering the set point in the process. And I mean, it could be quite substantial. For instance, if you're producing a 10 millimeter thick panel, if you reduce the thickness with 1/10 of a millimeter, that increases perhaps the production with 1%. That can be really substantial. We have a network-based system, so you can look at the measurements in many places in the factory, and you get production reports and statistics. Then there are some people using contact rollers in their measurement system. We think it's better with laser measurement. So by that we can measure soft materials like not dry fiber cement boards. You will get no contact with the product, so you will get no polishing of scratch marks, important in the finish line of the sanders. You will not get any compression of the material. And we measure 2,000 times every second. That means that we can measure at the very front edges of panels. That is typically important of the sanders and in other types of operations. No moving parts means we have no mechanical wear. That means that we get low maintenance costs. So different applications we can measure most places. It could be of the drums and the presses, or the dryers, the sanding, finishing lines. And we not only measure thickness, we can measure width and length, and also the flatness profiles of the panels. And by using only sensors, it's possible to have a level measurement in silos, for instance, or general positioning. Also over longer distances of 30 meters is quite possible. There is the sketch really from wood panels industry. But I mean, it's like with the presses, forming place, saw lines, sanding lines, finishing lines. We can measure in most positions with our system. We measure early in the line, then you get early fault detection, and then you probably need to have a single-sided measurement. And it's a tough environment, so we have rotation equipment for that, fans and rotation boxes. When we measure further down the line, more final products, then you do that to verify that your product is within tolerance. I mean, you don't want to send panels to your customers that is out of tolerance within the thing. You also get the feedback from your process equipment, like you can see if the sanding pads are okay or not with the measurement system. You can avoid sanding out too much, and you get documentation. Here is a system after a fiber cement sander. You can see here 1, 2, 3. That's the measurement track. You see the laser signal from the upper sensors that are in this protection box here, and you have equally sensors from the lower side. We have different types of systems. The most used one, the first one is with a fixed measurement track system. It's a selectable number of measurement tracks, but they are fixed. Then we have this single track system, only one measurement track. We have the traversing system with one pair of laser sensors traversing across the product. Then we have the width adjustable one, adjusting the width of the outer sensors, so you measure at the outer edges of the panels. It's useful when you have products with different widths. And And then we have this combined system where we can combine 2 or 3 measurement stations into one system computer. Here's the one with a fixed 3-track system here with the protection box side open so you can see the sensors. It's a movie about the fixed track system in the fiber cement sander. It's not very exciting, but that's how it looks like. Yeah. All our systems has environmental protection, so that's what we have here. We have protection boxes and we have a fan with spiral tubes that creates a high overpressure in these protection boxes with only small openings for the laser light to come out to the heat and heat from the water and moisture and debris and whatever. It's a single track system. See that there's 1 pair of sensors. We have a smaller fan for that system. There is an installation in this is a gypsum board line in the single track system. The gypsum lines we measure at the transfer table. That's when the handle goes sideways and we get a complete thickness cross profile. Here we have the traversing frame. You can see there is 1 pair of sensors rather slowly moving from one side to the other to give a complete thickness cross profile. Here we have another show. This is for XPS, extruded polystyrene, but it shows you the traversing. We have opened this plate of the measurement frame there. During installation, there's a bit of the frame of the sensor there, sort of automatically motorized move to the outer edges of the panel or high accuracy, accurate sensors, and stable, mechanically stable measurement frames. So we have a resolution in the system of 100 and accuracy of 200 millimeters. It's nearly always enough. Mechanical frames is a business measurement we work with, so it's very important that we have a temperature stable mechanical frame in all installations, and also they should be mechanically stable. So we use special design with that, with special methods. So we use inbar alloy in the vertical boards with low temperature expansion coefficient. If we had used aluminium or stainless steel, it would be much worse. Accuracy. And we also, all metals have inbuilt mechanical stresses, so we remove them by stress relieving, annealing them. It's sort of a heat treatment of the metal. It's not proper science. Otherwise, if the frame is bending and twisting, it would affect the measurement accuracy. What we also have, we have this inner frame. That is the important part of the frame. That is hanging in steel wire, so it's isolated from the sort of outer world. The outer frame is just standard aluminium profile. So that was the hardware. Now over to the software. I mean, we could say that we probably have all software functions that you need. Here you can have a look at the number of screens that follows. Here you see the operator software with the 3 measurement tracks. You have the thickness on the y-axis and the position of the panel on the x-axis. You can see here the graphics of the 3 measurement tracks. Here we have a color system telling you that red, your output tolerance. You can see that here you are below this red line. This is a lower tolerance limit, and this is the upper tolerance limit. And the yellow lines are warning limits, indicating that you are still within tolerance, but it's starting to get wrong, perhaps. And what we also have, we have these trending diagrams. There are a trending diagram for max and mean thickness for every board. This trending is to see slow changes that you don't see from one panel to the other. We also have the log points that is the positions along the panel where you want to have a highlight of the measurements. Typically it's in the front and at the left end of the panels that you set up these log points. Here we have another trending diagram. That's the average thickness for each track. This can be used for instance, after a sander. If one track is slowly getting higher, it could be indication that the sanding belt is wearing out. Here we have this three-dimensional view. So the system makes a transition between the three tracks, but it gives you an impression of what the panel looks like with the same type of coloring system for the output tolerance conditions. And you can also have a separate look at the trend graphs in one display that include the length and width measurement. If you have that gypsum, they always measure the width of the product. What the system also can do is to measure the panel flatness along the panel and across the panel. And you can set up these limits in the recipe handling of the system to get the long thickness like this. It's easy to calibrate. You don't have to do any mechanical fine-tuning. You do the calibration by the software. Either you run the panel through the system or you use one of the calibration tools, and then you will see you just press this button. You can log all measurements, of course. You can select if you want to log every day or every shift or every product run or whatever, and you can decide where you want to store all log data for all panels. It will be on the system computer or some other computer network to the system. You can search for earlier stored products. You can search for a certain hour or day or whatever. So it could be good if you have if you got claims from your customer. You can go back and look at what the panel looks like at that. And when you want only one, you can read reports. Typically, panel will start and stop of the product, and how many panels you run, how many panels have been out of tolerance. You get the capability indexes, CP and CPK. You're interested in that. And then finally, this I don't know how I quick now. There you see the software for the traverse, and it's the same software we have in the gypsum, so here you can see the paper, so you get the complete combined profile, and you can